Unit 5 Project, Linear versus Exponential by Shreya and Shea Stevens. Oh, linear decay. There is a fatal disease right now in a small country killing people yearly. The initial population is 400,000 people. Each year, the population shrinks by 50,000 people.
Is our decay table. This shows that every year it decreases by 50,000. So for the first year, so for the 0 year, we have to put 400,000 since that's the initial value and the y-intercept. So each year it decreases by 50,000. 400 minus 50 equals 350. So it would be 350,000. So and so on and so forth until you get to the prediction value, which is 100,000. This is the graph. The graph, how you space it and how you do it is up to you. But in the end, it should be going down where it's like a line. And if it doesn't, then you must have done something wrong and you need to check
That's
over
exactly
your work.
what the question. Go.
Wait, is this linear?
Yes. Linear growth. Go. Quickly. Faster.
I can't hear my voice.
Are you guys?
These are the linear decay equations. This is the recursive rule. It says now minus 50,000 equals next. The start is 400,000. And the explicit rule is y equals 400,000 minus 50,000 x. And if it's not that, then you need to check your work. So this is leading to the prediction. In year 7, what will be the population? So that means so you need to plug in your equation. Y equals 50,000. So the equation is 400,000 minus 50,000 x. So the x, plug in 7 for x and you'll get your answer. This is a linear growth problem. It says after 7 years of fatal disease, they found a vaccine that prevents it. Everyone in the small country got the vaccine and nobody else has died. The population right now is 50,000 people, and each year the population goes by 9,000 people. This is the linear growth table. It grows by 9,000 each year, so 50,000 plus 9,000 is 59,000, and so on and so forth until you get to the end. This is the linear growth graph. It should be going up linearly, like a line. If it isn't, then you need to check your work. Make sure your numbers are evenly spaced. This is the linear growth equation. So the recursive says now plus 9,000 equals next, and the start is 50,000. This is the explicit equation. It says y equals 9,000 x plus 50,000. And here's the key, is the prediction for year 12. And if you got this right, then good job. This is the exponential growth problem. If you can't see it, this is what it says. There are 400,000 people living in Pokeville. Sorry, I didn't include it in Pokeville. Each year, the population increases by 7%. By how many years should the population reach 600,000?
All right, 15 minutes left.
Quicker.
That doesn't help me.
Could if you. What will help you right now? What can I do?
Ashley, no one cares. We're loud.
No.
What? Linear exponential.
Yeah, Shay, this didn't turn out
You
good.
need questions, not equations.
Oh, thanks. This is the exponential table. The equation is y equal. This is the exponential table for growth, and the equation is right here. It says y equals 400,000 times 1.07 to the x power. This is the exponential growth graph. It should be going up slope, like a slope. And if it isn't, then you must have done something wrong and you need to recheck your work. Make sure your numbers are evenly spaced. This is the recursive rule for growth. And if you can't see it, it says now times 1.07 equals next. And the start is 400,000. This is the explicit rule. If you can't see it, it says 400,000 times 1.07x. This is the exponential decay problem. It says, oh no, the fatal polka dot disease has reached Pokeville. Each year the population decreases by 23%. By how many years will the population reach 100%? This is the exponential decay problem. If you had your equation right, this is how it should be going, and so on and so forth until you've reached 100,000. This is my exponential decay graph. If it's going down like a slope, then you're doing it right. If not, then you must have done something wrong and you need to check your work again. Make sure your numbers are evenly spaced, and you need to label your axes and all that. This is the exponential decay recursive rule. It says next equals now times 0.77 by 0.77. The start is 400,000. This is the exponential decay explicit rule. If you got confused with what the start value is for the decay, it's 400,000. It's still the same. And then you multiply by 0.77x. So, if you have all your equations right and you've done your table and graph right, this is your prediction. In 5.3 years, the population will reach 100,000. This is the end of this video. Thanks for watching. Bye!